I know what 1 divided by 0 really is. As infinity and undefined battle over which one it is, another warrior comes into the fight. It is none other than the mighty number 0. But how is this the case? We know that 0 times anything is 0, especially 0. So, how and why? We shall start with an equation. 1 over n is equal to n. You might see where this is going, but please bear with me. We will now multiply both sides by n squared to get 1 over n times n squared is equal to n times n squared. This simplifies eventually to n is equal to n cubed. Now we subtract n from both sides, which gives us n minus n is equal to n cubed minus n, and simplifies to 0 is equal to n cubed minus n, and when flipped, n cubed minus n is equal to 0. Now we factor out n to get n times n squared minus 1 is equal to 0. How these work is that either n is 0 or n squared minus 1 is 0, because 0 times anything is 0. But now we will suppose that n is 0 in this case. Taking our original equation of 1 over n is equal to n and substituting in this n is equal to 0, we will get, you guessed it, 1 over 0 is equal to 0. And there we have it. Take a photo or a screenshot, hang it up on your wall. Here it is. 1 divided by 0 is equal to 0, proven. The truth is, though, I can give a solution of 0 for any equation. So let me find one for you, and I'll do it right now. So now I'll search up a quadratic equation in my Google server, and I'll generate one, and I'll click on GeoGebra's random quadratic equations, and as you can see, these have complex solutions, and none of them are 0. So I'll take the first one, 5x squared minus 3x plus 5 is equal to 0, and I'll solve it, and I'll make sure that x is 0. And I'll multiply by x, but hold on. Let's bring in our original equation, which was n is equal to 1 over n. And that first step was multiplying by n squared to get n cubed is equal to n. But the thing is, both first steps multiplied by the variable or a power of it, x or n squared, and the resulting equation has no constants except 0. And you can now see the similar structure if I subtract n from both sides in the second equation. Let's solve these in parallel now, and you can see the similarities. So we'll factor out the x and the n. But for the quadratic, we now have x times the original quadratic, 5x squared minus 3x plus 5, that we started with. You may also notice that if 1 over n is subtracted from n, like in an original equation, and then the expression is multiplied by n, which is n squared divided by n, we get n squared minus 1, which is multiplied by n here. So this is very interesting. The false proof goes, now x or n is 0, or the expression is 0, as 0 times anything is 0. This model is successfully used in quadratic equations, but here x is 0, and 0 is not a solution, and 1 divided by 0 cannot be 0. Something went wrong, and I'll show you what did. The candidate x and n, to be 0, were not there originally. We multiplied them on while we were trying to prove this. So in short, these proofs take advantage of the fact that 0 times anything is 0 by multiplying an expression by a variable, which pretty much makes the expression not needed and mitigates it equal to 0, and setting that expression to 0 by making some steps, like making a quadratic equal to 0. Now, we'll prove this result using Wolfram alpha. So I'll type in our quadratic. 5x squared minus 3x plus 5 is equal to 0. And that plot does not touch the y equals 0 line. And we have two complex solutions, the same ones that were mentioned. And now I'll multiply x by the whole thing, like we had a few steps later. And this in the root plot and in the real solutions tab will give us a solution of 0. Now, if I multiply each term by x, we should expect the same result. And in a minute, I'll show you what we do get. And what we actually get is, what do you know? It is 0. So now we'll type in our second equation. 1 over n is equal to n. And we'll get the solutions 1 and minus 1. Because 1 divided by 1 is 1. And 1 divided by minus 1 is minus 1. So that makes a lot of sense. But now I'll multiply both sides by n squared. Sorry for the sudden change of scene. And something very weird happened when I was recording this. You'll see that in a minute. But what happened was, on the root plot, it does show us the solution of 0. But here it says the alternate form is for n not equal to 0. And the solutions, you can't see it, but it did not show 0. Not even on the number line. But not to worry, it does show you somewhere, and I'm sure that this result is legitimate because it shows it directly in the root plot where my cursor is. So now I'll type in as n is equal to n cubed, what we got a few steps later, and here it shows us 0 on the number line, and it does in the solutions as well. And the alternate form does not say for n is not equal to 0. Thank you for watching. I hope you enjoyed this video. Please don't forget to like, share, comment and subscribe if you enjoyed. Thank you for watching.